Hey, boys and girls, we're going to do some more discussion and exploration into circles and angles and lines. We already have a triangle that lies on the chord, a triangle that lies on the diameter. We have that the tangent line is perpendicular to the radius at the point of tangency. So we're going to do a couple more, okay? So check this out. We've got a central angle right here. Central angle starts at the center. That's where the vertex is. And an inscribed angle has the vertex on the edge. If they have the same intersecting arc, then this angle right here is going to be double of that angle right there. So for example, if this was 100 degrees, this one would be 50. Now the intercepting arc, another way to talk about that, what a lot of places refer to that is they say that they lie on the same chord. So you could draw a chord from those two intersection points. So we're talking about where the side intersects the circle. That creates an arc. It's called the intercepting arc. And so if the central angle, which comes from the center, the vertex is at the center, and the inscribed angle, whose vertex is on the edge, if they have the same intersection points, the same exiting points, then they're going to be congruent to each other. So these two angles right here, they exit the circle right here and right here. So those are the intersection points. So they are going to have this property, okay? So there we go. So whatever this central angle is, the inscribed angle is going to be half. Now here we have a couple of angles. Now this is not a central angle because the center is right here. So this right here is not a central angle, neither is this, okay? But what we have is we have a couple of things going on here. So first of all, you see this angle right here and this angle right here? They go through these exits. They're both inscribed. They're going to be equal to each other. Same with these two angles here on the top with the double arcs. They see this angle right here exits here, and this one exits here. So they exit here and here. Well, the other angle does exactly the same way. It exits exactly the same way. So here and here. So that's where this angle exits. So you got this side right, this side right here exits there. This side of the angle exits there. Well, that's the same as for this angle, though, so those two angles are the same. Now, here's the other thing that's not on the screen right now, but is absolutely true. If these arcs here were equal, then all four of these angles would be the same. So if you have an inscribed angle, and they don't share the same intersecting arc, but the arc length is the same, they're also going to be equal to each other. All right, so next one. Now, this is kind of strange right here. This is a reflex angle. Do you see? But it is still central. This is inscribed. They have the same intersecting arc. Do you see this inscribed angle right here has this intersecting arc? This central angle has the same. So the thing is whatever this angle is, this central angle is going to be double of this inscribed angle. So this, if this was 300, this would be 150. All right. One thing I'd suggest is that you go back and carefully draw each one of these and construct them, just to make sure you got a solid understanding. All right, now let's talk about a circle with a chord. So this circle right here has this chord going through it. Let's say you did not know where the center was. You could actually do a bisector, a perpendicular bisector of this chord, and it would pass through the center of the circle. So it would bisect these two parts and go through the center, making a 90-degree angle. Another thing is if you have two chords that are of the same exact length, they're going to be equal distance from the center of the circle. Yeah. So go back, draw these very, very carefully, like I did this one right here. Like I did this one right here. I drew a circle. I constructed two chords that were the same length, and then I measured the perpendicular distance from that chord to the center, and they were both the same, and that's what you should end up finding out. So, for example, well, here, let's do one really quickly. Let's see here. Let's see. You should be able to see my document camera now. Let's zoom in just a little bit. So let's say this is our circle right there. Let's see, that's our center. So here comes a circle. Boom, done. Man, that's fancy. Look at that. So that's our circle right there. Now, where did my straight edge go? There it is. So let's say we have some random chord, and let's say we didn't actually know where that center was. So we did not know where the center was, and we wanted to find it. Well, what you could do, all you got to do is make a perpendicular bisector for this segment. So I got to make my compass open at least halfway. All right, that looks like at least halfway. So I'm going to make my arc here. I'm going to make my other arc arc here. All right. Now, let's see here. Yeah, you guys can see all that. So if I connect these two dots right here, that will pass through the center. This is going to be 90 degrees. Each of these two will be the same length. So it works, see? All right. Last new fact. Let's say we have a circle and we draw a quadrilateral that's inscribed. All right, so here's a quadrilateral that's inscribed. So the thing that's going to end up happening is these opposite angles, like this angle right here and this angle right here, they're supplementary. These two angles right here and right here are supplementary as well. So these will make 180, these will make 180. That's how it works. So for example, let's say we've got this right here. This is actually a cyclic quadrilateral, right? So it's got 1, 2, 3, 4 sides. It's also, there's also in here a triangle that lies on the diameter. So this is going to be 90 right here. That's going to be 90 degrees right here. But here's the thing. This angle here is opposite to this angle right here. So that angle right there is going to be 75 degrees because they have to be supplementary, you see? Okay, very good. So if we take a look at all of the things, I'm just going to throw it up here for us here. These are all of the pieces of information that we have, right? Opposite angles of a cyclic quadrilateral is supplementary. We got all of that stuff. Boom, man, that's fancy. So let's walk through a couple of examples, right? Because none of these facts are difficult, but what's difficult is making use of those facts, recognizing what's in front of you. So let's take a look at this one right here. We've got this circle. We've got a couple triangles in there. So I know that this right here is a 90 degree. This is a right triangle right here. This is a right triangle because this is a triangle that lies on the diameter, right? So x plus 2x has to equal 90. That makes x equal to 30. If you solve this, you get x, 3x equals 90, so x is 30. So I'm going to go ahead and write this on here. That's 30, and that's 60. Do you see? Okay. Now, here's the other thing. This is another right triangle because it's an inscribed triangle that lies on the diameter. So if that's 30, this is 60. And that makes this 60. And the reason I know this is 60 is because look at this side right here and this side right here. Do you see this is the intercepting arc? A and this lie on the same arc. They're both inscribed, so they're 60 and 60. Okay. That makes this 120, which makes this 120. Do you see? This is 120 degrees. The reason these are vertical, so they're the same. The reason I know this one's 120 is it's a central angle that lies on this intercepting arc. It's double of that. All right. Now let's see here. Let's see. Can we find B? Oh yeah, B has to be 30 because look at this triangle right here. This is a 60 right. This is a right triangle. One of the angles is 60. The other has to be 90. All right. Now angle D. There's a couple ways we could find out angle D. It has to be supplementary to this because look at this right here. This is a cyclic quadrilateral. There's one side, there's two sides, there's three, there's four. These are opposite of each other. So this is D is 120 for sure. There's another way to know that D is 120. Do you see? Look at this angle. Look at this central angle right here. Look at that central angle. Look at this intercepting arc. This arc. Look at this arc out here. So this angle right here is going to be 240 degrees. It's 120 minus 360 minus 120. This is going to be half of that because this is the intercepting arc for that inscribed angle and this central angle, which is 240. So that's going to be half 120. Man, this is just fancy. Moving on. Let's see. Next up, buttercup. Okay, this is kind of an ugly thing here. See these marks right here? That means these two things are equal. Oh, wow. So, actually, oh, interesting. Okay, so look at this right here. You see that right there? That's 25. This is the intercepting arc. This angle right here has that same intercepting arc, so this is 25 degrees, which makes this part 55 degrees, right? That's 55 because that's 25. They make 80 together. So look at this intercepting arc over here. That's for this angle. You can follow it all the way across, right? You see? This angle has this intercepting arc. They're the same, so this is 55 degrees. Oh, yeah, yeah, yeah. All right, so now here's what we've got. We got a 55. We've got an 80. So that makes this 45 because this is a triangle. And that lies on this chord, or this has that intersecting, or that intercepting arc. So there we go. Man. Okay, moving on. Man, good idea to try these on your own too, right? So here's what we've got here. This is a funky one. Wow. Um, hmm. So I've got this intercepting arc from A to B and from D to B, or sorry, A to D. These are the same. Wow, this is a funky one. So that makes this 38 degrees as well, because this is the intercepting arc for this angle, and it's marked as the same as this intercepting arc for that angle, right? So that makes together 76. So if you subtract 180 from that, you're going to get 104. So this is a 104 degree angle right there. Oh, man. All right. So let's see. BAD, we got 140. AED. Wait, where's the E? Oh, I don't see an E. Huh. Interesting. Okay, ACD. Oh, ACD. That would be this one right here. We don't have that on there. That's 90. Connect AC. Yeah, that's 90. Now, AED. What could that one be? Oh, I see what the problem is. Got a typo here. One of these is supposed to be E. I'm not really sure which. So, all right. Well, let's say this one. Let's say this one right here is E. Let's see if we can figure this out. So we got this triangle right here, right? This angle's way outside. That's 140 degrees. This part's 38. Let's see. Oh, I think we got a clue right here. So this is 90, right? Oh, look at that. This is a 38 degree angle too. That's a 38 degree angle too. So let me show you why I say that. All right, check this out. See this angle right here? This is 38 degrees. And the reason I know that's true is it's an inscribed angle that lies on this chord. This inscribed angle lies on the same chord. That's 38. This is 90. So look at this. Look at this is 90 right here. Okay, which makes, we know the whole thing's 140. We already know that the whole thing's 140. Okay, but inside of here we've got we've got a right triangle, right? Well, here I'll draw it in the same orientation. Sorry about that. All right, so we got the base, right? And then we've got a right triangle right here. We know this is 38 degrees right here. And so this entire angle is this entire angle. Do you see? So these two have to add up to 90, so this is going to be 52. So this whole thing right here is 52. So I don't know if this one would be 52 would be the right answer if like this was the E and that was supposed to be D. Either way, this one's going to be 38, right? 38 degrees there too. So I'm not sure which was really E and which was D. I kind of made it up, but we got the idea. Okay, almost done. In fact, we are done. I take it back. Man, I hope this has been helpful and useful. Try these problems. I mean, they take a long time to do. I've done these. I've been teaching this for a while today. It's fresh in my mind. That's why I decided to make the video. But yeah, just go back to, look, here's what you should do. Make sure you're using these. When you look at those pictures, how can I use, which one of these things is going to be useful? And you have some others that are not on here, like we were talking about with the triangle that lies on the diameter. The inscribed triangle lies on the diameter, and a tangent line being perpendicular to the radius. All those kinds of things. So anyway, I hope you guys are having a good day, and I'll see you soon.